Math 161, ellipse, second example. Again, the standard equation for an ellipse with center HK, x radius A, and y radius B is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. In this example, we have an equation 8x squared plus y squared minus 24x plus 2y equals negative 17. Because we have an x squared and a y squared term and they're both the same sign, it could be an ellipse. It could be also it could be no solution, but if it's not, if it does have a solution, it will be an ellipse, and we want to try to put it in this form to try to determine the features of the ellipse. Okay, so we want to put first of all put x with x and y with y. So I rearranged the order of the terms here. That'll give us 8x squared minus 24x plus y squared plus 2y equals negative 17. And then we want to factor the leading coefficient of each variable separately. So there's an 8 in front of the x squared. I factor that out. Divide each coefficient by 8. And inside parentheses we'll have x squared minus 3x. Leading coefficient of y squared is a 1, so we factor out a 1 for the y terms. Divide anything divided by 1 is itself. So we'll have 1 times the quantity, y squared plus 2y equals negative 17. Okay, and now we want to determine what numbers we can add to make these expressions into perfect squares. So we want to take half the coefficient of x, half of 3 is 3 halves, and square it. 3 halves squared is 9/4. 3 squared is 9, 2 squared is 4. And then likewise with the y terms, take half of the coefficient of y and square that. Half of 2 is 1, 1 squared is 1. So that tells us what we have to add to make these into perfect squares. So we want to add 9/4 to the x term, and add a 1 to the y terms. And in order to keep this equation equivalent to the original equation, we need to add the same thing to the other side of the equal sign. So the 9/4 that we added was inside parentheses with the 8 on the outside, so we want to add 8 times 9/4. And the 1 that we added is inside parentheses with the 1 on the outside, so we want to add 1 times 1. Okay, so now we can factor these. We need two numbers, x times x is x squared. We need two numbers that multiply to 9/4 and add up to negative 3. And the numbers that work are negative 3 halves and negative 3 halves. And you can check by multiplying. X times x is x squared. Outer product is negative 3 halves x. Inner product is negative 3 halves x. Add those, you get negative 6 halves x, which reduces to negative 3x. Last times last, 3 times 3 is 9, 2 times 2 is 4. Likewise with the y terms, we'll have y times y to give us y squared, and then we need two numbers to multiply to 1 and add up to 2. And the numbers that work are 1 and 1. And again, you can check with the FOIL method. On the right side of the equal sign, we can do the operations here. 4 into 8 goes 2 times. 2 times 9 is 18. Negative 17 plus 18 is 1, and 1 plus 1 is 2. So these all, when you can do the operations here, it comes out to be 2. Okay, so now we can write the equation more compactly in step 6 with using exponents. So this will be 8 times the quantity x minus 3 halves quantity squared, and 1 times the quantity y plus 1 quantity squared. So now it's starting to look like the form that we want, but instead of an equals 2, the form that we want has an equals 1 there. So in order to get an equals 1, we want to divide each term by 2. Okay, and then we can reduce those. 2 into 8 goes 4 times, and 2 into 2 goes 1. So we can then reduce those to simplify it. Okay, so the new expression, step 8, 4 times the quantity x minus 3 halves quantity squared over 1 plus y plus 1 quantity squared over 2 equals 1. Okay, so in the expression we do not have a number, a coefficient in front of the x. So we're going to get rid of that 4, and we can do that by multiplying by 1/4. The reciprocal of 4 is 1 over 4. So if we multiply top and bottom of the fraction by the same number, the fraction will be an equivalent fraction. So to multiply top and bottom by 1/4, 1/4 of 4 is 1, so that'll cancel, and on the bottom we'll have a 1/4. So the new expression is x minus 3/2 quantity squared over 1/4 plus y plus 1 quantity squared over 2 is equal to 1. So now, actually, sometimes the book will actually stop on this step here because it's close enough to the form that we can identify the features of the graph. But if we want to exactly match it to the form, instead of a number on the bottom, we have a number squared. So 1/2 squared, replace the 1/4 by 1/2 squared if you want to exactly match the form. 2 is not a perfect square, but we can just leave it in radical form. Root 2 squared is the same as 2. And also, in the form that we're looking for, instead of a plus sign here, we want a minus sign. So if we put a double negative, that'll give us the minus sign. And then we can identify the features of the graph. H is the number inside parentheses with the x, so h is going to be 3/2. K is the number inside parentheses with the y, so k will be -1. A is the number underneath the x, that's 1/2. B is the number underneath the y, which is square root of 2. We can use trial and error to estimate square root of 2. Square root of 2 is approximately 1.4. So for graphing purposes, it'll be helpful to estimate that. You can do it by trial and error. 1 squared is too big. I'm too small, rather. 1 squared is 1, which is too small. 2 squared is 4, which is too big. So we know it's going to be somewhere in between. 1.5 squared is 2.25, which is a little bit too big. So anyway, by trial and error, it comes out to be about 1.4. Okay, so the center of the ellipse, HK, is going to be 3/2 comma -1. It may be helpful to put this in decimal form. As a decimal, 3/2 is the same as 1.5. It's 1 1/2, which is 1.5. And from the center, we can go up and down 1.4. B is approximately 1.4. So we go up and down 1.4 from the center to identify the vertices. So from the center, we'll up 1.4. This red dot here is a vertex, and go down 1.4. That's also a vertex. The center is 1.5, and to the right down 1. Okay, and then from the center, if we go, A is 1/2, which is about 0.5. If we go left and right 0.5 from the center, we get the two co-vertices. Okay, so then once we plot the vertices and co-vertices, we can connect the dots, and that gives us an ellipse. Now, for some applications, it's important to know some of the other features. If you connect the two co-vertices, that's called the minor axis. The line segment connecting the two vertices is called the major axis. And there's also a special point called the focus, and there's a formula for finding the focus. So C, to get the focus, we compute C, which is square root of a squared minus b squared. In this case, it's 0.5 squared minus root 2 squared. 0.5 squared is 0.25. Root 2 squared is 2. 0.25 minus 2 is -1.75. Take the absolute value of that, you get 1.75, and then you want to take the square root. And again, you can use trial and error. 1.3 squared is about 1.69, which is pretty close. And so it's about 1.3. 1.4 squared is 1.96, which is a little too big. So the foci will be on the major axis, approximately 1.3 units from the center. So let's go back to the graph here. and that's where you go from the center, go up 1.3 and down 1.3. These black dots are the foci, and they're important in some applications. And that concludes this presentation.